Welcome my dear friends, this is Dr. Satvir here back with another video. This time the topic of the video is analysis of periodic and aperiodic signals. In this video I'll take up and solve some numerical problems from the previous examinations for better understanding of the concepts. If you are new to my channel, let me tell you that full course videos on signals and systems and their PPTs are available at drsatvir.in. The link is given in the description. Now let us start with the video. By definition, a signal xt is said to be a periodic signal if it repeats after a finite time interval, say capital T0. Mathematically, xt should be equal to xt plus capital T0, where capital T0 is called the fundamental time period of the signal, and f0, that is equal to 1 upon T0, is called its fundamental frequency. The examples of two periodical signals are shown in these two figures. First one is showing one square wave that repeats after an interval of time period T0. The second figure is showing a sinusoidal waveform, and that is also repeating after a time interval of a T0. Whereas an aperiodic or non-periodic signal never repeats afterwards. In other words, it repeats after an infinite time. That is, the time period capital T0 is tending to be infinity in case of aperiodic or non-periodic signals. An example of an aperiodic signal is shown in the third figure, where the signal never repeats afterwards. When two periodical signals having same frequencies are added or subtracted, then their resultant is going to be a periodic signal. For example, xpd, which is equal to a sine of omega t plus b cos of omega t, is a periodical signal. However, a resultant signal may be periodic or aperiodic when two periodical signals having different frequencies are added or subtracted. Let us take up two examples. xpt, which is equal to a sine of omega t plus b cos of 2 omega t, is a periodical signal, whereas signal xat, which is equal to a sine of pi t plus b cos of 50t, is an aperiodic signal. Now let us take up one numerical problem from the previous examinations as a practice problem, where we need to test the periodicity of a continuous time signal yt, which is equal to sine square t, using trigonometric formula cos of 2 theta is equal to 1 minus 2 sine square theta. Signal yt can be rewritten as yt is equal to 1 minus cos of 2t upon 2, which is equal to 1 upon 2 minus 1 upon 2 cos of 2t. The first component does not contribute toward the periodicity of the signal, whereas the second component is a periodical part. Therefore, signal yt as a whole is a periodical signal whose fundamental time period of the signal is given as T0, which is equal to 2 pi upon omega. Omega in this case is 2, therefore the signal time period is 2 pi upon t, which is equal to pi. Now let us take up one numerical problem from the previous examinations of signals and systems, where we need to test a periodicity of a discrete time signal yn, which is equal to cos square pi by 4 into n. Using trigonometric formula cos of 2 theta is equal to cos square theta minus 1, signal yn can be rewritten as yn is equal to 1 by 2 into 1 plus cos of 2 into pi by 4 into n is equal to 1 by 2 plus 1 by 2 cos of pi by 2 into n. Since the first component is DC and second one is periodical part, therefore signal yn as a whole is a periodical signal whose fundamental time period is given as capital T0 is equal to 2 pi upon omega. In this case, omega is equal to pi by 2. Therefore, the total time period T0 is going to be equal to 4. Now let us take up third numerical problem from the previous examinations, where we need to determine the periodicity of a signal xt, which is equal to 10 cos of 10t minus pi by 2 minus 4 sine 4t minus pi by 5. It is important to observe here that xt is a subtraction of two periodical signals having different frequencies. Let us assume x1t is the first component of the signal xt, which is equal to 10 cos of 10t minus pi by 2, and x2t is the second component of the xt, which is equal to 4 sine of 4t minus pi by 5. Now the fundamental time period of the first component, that is x1t, is given as t1 equal to 2 pi upon omega 1, where omega 1 is equal to 10, therefore t1 is equal to 2 pi upon 10. Similarly, the fundamental time period of the second component x2t is given as t2 which is equal to 2 pi upon omega 2, which is equal to 2 pi upon 4, since the 4 is the value of the omega 2. To determine the periodicity of the signal xt, we need to know the ratio of t1 and t2, which is equal to 2 pi by 10 divided by 2 pi by 4, which is equal to 4 by 10. This is a rational number, therefore the signal xt is a periodical signal. If this ratio of t1 and t2 would have been an irrational number, then the signal would have been a aperiodic signal. Since it is a periodical signal, therefore the fundamental time period is to be calculated for this case. Now the fundamental time period of the signal xt is given by the formula LCM of the numerators of t1 and t2 and HCF of the denominators of t1 and t2, which is equal to LCM of pi and HCF of 10 and 4, which is equal to 2 pi by 2, which is further equal to pi, and hence the fundamental time period of the signal xt is equal to pi. Now let us consider the fourth numerical problem that appeared in the previous examinations of signals and system. In this, we need to determine the periodicity of the signal xt, which is equal to cos of 5t sine of pi t. Now let us assume x1t is the first component of the signal xt, which is equal to cos of 5t, and x2t is second component of the signal, and which is equal to sine of pi t. Now the fundamental time period of the first component is t1, which is equal to 2 pi upon omega 1. In this case omega is 5, therefore t1 is equal to 2 pi upon 5. Similarly, the fundamental time period of the signal x2t is t2, which is equal to 2 pi upon omega 2. In this case omega 2 is equal to pi, therefore t2 is going to be equal to 2. Now to determine the periodicity of the signal, we need to know the ratio of t1 and t2, which is equal to 2 pi upon 5 divided by 2 by 1, which is equal to 2 pi upon 10. Since this is an irrational number, therefore the signal xt is a aperiodic signal. Now let us conclude this video by floating some more questions from exam point of view. Compare periodic and non-periodic signals. 2. Comment on the periodicity of the signal given by xt is equal to a sine square t. 3. Find the periodicity of the signal yt equal to cos square 2t. 4. Prove the periodicity of the signal yt equal to e raised to power j omega t for omega not equal to 0. If the signal is given by xt, which is equal to 5 cos of 5t minus pi by 2 plus 4 sine of 10t minus pi by 5, then determine its periodicity. If it is a periodical signal, then determine its fundamental time period. 6. Determine the periodicity of the signal given by xt equal to 5 cos of pi t minus 5 plus 4 sine 10t plus 10. 7. Determine the fundamental time period of the following signals. First one is a continuous time signal, which is equal to cos square 3 pi t. The second one is discrete time signal, which is given by sine square pi by 4 n. Thank you, my dear students. Please do subscribe, like and share this video with your friends. In the next video, I will be talking about analysis of even and odd signals. Thank you very much.